and we are just checking C. Okay, I'm just checking something over here. I want to see how this looks. This is my channel, and I want to see how it looks live. Let's go ahead and check this out. This is my channel, and I want to see how it looks live. Let's go ahead and check this out. This is my channel, and I want to see how it looks live. Let's go ahead and check this out. Okay, so what are we doing now? So basically, this is what it is, right? So here we have Python basics made easy, variables, data types, collections explained. So the first thing that we will understand is what variables are, right? Learn how to declare and use variables in Python, and then we will do the collections, which is discover Python's powerful built-in data structures. Okay, there are many data structures in Python, and we will look at collections as well. So understanding variables to begin with. So the first thing that we have is there are two concepts over here to cover, two key concepts to cover. Variable declaration and assignment, which will allow you to assign values to them. And then we have the basic data types, which will we will explore the fundamental built-in data types in Python, okay, basic data types. So the first is naming conventions. You have valid names and reserved keywords. What are the valid names when you go ahead and use Python? Python variable names, we will discover it here. Then we have dynamic typing, variable naming conventions, rules are valid, rules for valid and readable variable names. Then we have valid names, which are examples of accepted variable names. Then we have reserved words, which are not allowed as variable names. Then we have dynamic typing. What is dynamic typing? It is flexible approach to variable types. And we have inference. Python automatically determines the data type based on the value. And then we have reassignment, changing a variable's value and type dynamically. So the first thing that we are going to do is understanding variables. We'll start the programming ideally. I will start the ideally. I will go to Python. And here, this is the ideally. Once you open the Python ideally, it will come like this. Okay. First is understanding variables. Variables in Python are declared like this. For example, x is equals to 10. Okay. What I did now is this is a variable. Okay. This is how you declare and use variables in Python. I put x variable and I stored 10 inside it. I put 10 inside x variable. That is called as variable declaration and assignment, defining variables and assigning values to it. So we'll go ahead and check the rules, naming conventions for Python variables. So here we have We have something called a snake case, which is underscore. This is more widely accepted convention for variable names and function names. All words are lowercase and separated by underscores. So this is called as snake case. Okay. So for example, if I want to declare a variable called as number of items, I will just say number underscore of underscore items is equals to 10. And if I want to check what is inside that, I will just say print and then number underscore of underscore items. Understood, guys? It says 10 now. What is this called? This is called as snake case. The second is Pascal case. The second is Pascal case. This is standard convention for class names. We have when you are using classes, we will discuss what classes are later. But for this is standard convention for class names. The first letter of each word is capitalized with no underscores. So, for example, if I want to create a class called as user, I would just say user is equals to, and then I would just call something like this. I mean, that is how you do it basically. User, and then if you enter, it will say user is not defined. So you have to assign it something. I will assign it a value called as none. Okay. For now, what I did is I assigned a value called as none to the user. So if I say type of and then user, I just don't remember the don't remember how to use the type of. So it's okay. Next is screaming case. This convention is used for constants. For example, all the letters are capitalized with the words separated by underscores. Constraints are variables whose values are not meant to change during the program execution. Okay, these don't change in the program execution. I will declare a variable called as pi. I'll show you this a little later. Okay, pi is equals to 3.142222. And if I just say print and then if I do the value of pi, it will return it that. So here, the one useful feature is if I just try to assign 4 to it, if I assign 4 to it, it should not change. But then I don't know why it allowed it to change. And I will just say print and then pi, and it is 4 now. Basically, what happens is the pi value shouldn't change. But what is happening here is I didn't do it correctly. If I had done it correctly, it would just throw an error. Okay, I will show the example in a bit, but let's bear with me. Then bear with me. Then we have camel case, which is less common. While less common than snake case for variables in Python, you may encounter it, especially in older code or code ported from other languages. The first letter of the first word is lowercase, and the first letter of the subsequent word is capitalized. It will look like this. For example, first name is equals to a value such as Santosh. Okay, I will show you all these. Don't worry about it, but just bear with me. Then we have single letter underscore. A variable name preceded by a single underscore is a convention that indicates private or internal use variables. It is hint to other programmers that the variable should not be accessed or modified directly from outside the class or the module. So whenever you are declaring a class or a module in Python, then you use this. Okay. Now I will show you type of. Okay. Check type of variable in Python. Okay, so here you can see that Off is not there. Okay. What mistake I had done is I had put the off there. So here if I say print type of the variable name, for example, pi, you will see that it is integer variable. It has considered it as integer variable because the latest value is 4 over there. Okay. Then if I just do print type of uh, user, for example, that we created, it will say none type because we have assigned none to it, right? User is equals to none. Then you have the string, for example, print type of first name. What is it? First, okay. I will just do print type first name. My bad. It says string as you can see. I by mistake I am doing type of, which is in other programming languages we have something called as type of. Over here you just have to write type instead of type of, alright, and you will get the values. So welcome everyone. Thank you so much for joining. If you are here, please say hi or hello. Okay. Then that is about it when it comes to valid names. And here I will also ask it one thing. So here, okay, now we have that it is a typical behavior in Python is what they are saying. So whenever you declare a variable, whenever you see a screaming case which is widely adopted, it should not be changed. Okay, that is what it is. For example, over here, screaming case, it is used for constants. All letters are capitalized with words separated by underscores. Constants are variables whose values are not meant to change during the program execution. Okay, so here we can go ahead and check these things. So basically, we know what the valid variable names are now, right? We know what the valid variable names are. We don't know what reserve keywords are yet. So we will look at reserve keywords. All these are print and loop if else are all called as reserve keywords. So for example, if else, as I told you, for, while, break, continue, past, these are reserved keywords. The logical values such as true, false, none, and, or, not, in, is, are also reserved keywords. Okay, let's go ahead and take a look at these. So the first thing that we do is, for example, here, what I want to do is I want to close this and I want to reopen this. Let's reopen Python and we'll access the IDLE. Here we have the, for example, if I do if is equals to 10, you will see an error. It says invalid syntax. Why is that? Because if is a reserved keyword. If is a reserved keyword. However, if I just say f is equals to 10, it will take that value because it is A normal variable conversion, we are assigning an integer called as 10 to the f. Okay, we are assigning an integer called as 10 to the f. So if you want to print this, you can go ahead and print. Then that is done. So this is about the reserved keywords. Any doubts over here, guys? If you have any doubts in reserved keywords, let me know. Okay. Any doubts? Hello there. Welcome to the channel. And then we are conducting the Python class. You are welcome. If you have any doubts regarding, so we understood the variable names, learn how to declare and use the variables in type Python. Then we covered the variable assignment, defining variables and assigning values to them. Then we covered the naming conventions, rules for valid and readable names. Then we covered theoretical aspect and practical aspect of valid names, examples of accepted names and reserved keywords. So because this is done, I will just make this smaller, and over here I will cover the dynamic typing. Okay, what is dynamic typing? Python's flexible approach to variable types. For example, you see over here, when it is an integer declaration, we are assigning the value called as 10 and we are just saying f is equals to 10. Okay. Similarly, if I just say f is equals to 20.5 now, it is possible. And now if I print the value of x, f, it will print 20.5. But here, if you also learn the type function, type of f, if I do this, it says float now. Why is that? Because we are putting the value 20.5 inside it, because of which it is saying the type is float. But if you change it again, and if you just say f is equals to 2, and if you do type of f, it will say int now, right? Why is that? Because it is integer. That is called as dynamic typecasting of a variable, guys. Understood? Python's flexible approach to variable types is called as typecasting. Alright. Then we have type inference. Okay, type inference. Python automatically determines the type based on the value. We just saw an example of that. Dynamic typing is flexible approach to variable types. Then we have reassignment. Reassignment, changing the variable's value and type dynamically. For example, again, I will change this. The f was an integer value first time, then it was a float value. Now I will make it integer value. Now I will make it string value. F is equals to Santosh. Or tell me your name. I'll put your name. F is equals to Santosh. Now if I just do type of f, it will say str because it is a string. String is nothing but sequence of characters, guys. Alright? Understood what this is? Dynamic typing, we covered dynamic typing, we covered variable declaration and assignment. Now we will cover basic data types. So here we have numeric data types, which we already looked at. For example, I will just say dozen is equals to 12. That is a numeric data type. Now I will just say liters. Liter is equals to 12.5. That is the floating point data type. And I will just say Boolean data is equals to true. You have to do it like this, and I will just say type of dozen. It should say int, okay, and it said int. That is integer type of data. Then you have the liter, which is 12.5. So we'll just say type of liter. It just says float over there, as you can see, that is floating point value. Then we have the Boolean data type, which is a special one. So I will just say type of Boolean data. It will say bool over there, as you can see, because it has the variable has the assigned value of true. It is saying bool. Okay, those are your types. So understood, guys? Any doubts in basic data types? So here you can just read through as well. Represents truth value in logical expression, represents falsehood value in logical expressions. Here, if we look at this, true or false values for logical operations, that is Boolean type. Then we have floating point, numbers with decimal points, example 3.14, comma minus 0.5. Integers, the whole numbers without fractional parts, example 5, comma minus 10. Okay, so we understood all these things. Now I will minimize that and minimize that. Now we have working with collections. So what is collection? Working with collections. Here we will discover Python's powerful built-in data structures. Okay. Here we will look at that. So first is lists. Okay. First we will cover lists. Then we will look at the next one. Okay. What is a list? Ordered mutable sequence of items allowing duplicates. So we will cover lists now. Uh, First, we will look at list creation, how to make and retrieve elements in the list. Okay, we will cover this now. Uh, First one, we'll just go to Python create a list. So over here, first, this is how you initialize the empty list. I will make a list of fruits. Okay, I will make a list of fruits first. I will just paste this. So here we declared a list called as fruits, and I will declare a list called as numbers as well. I declare a list called as numbers, and I will declare a mixed list as well. Okay. Now we can go ahead and see what it is. Okay. Now if I just say print fruits of 0, okay. Okay, this is giving the entire fruit list. So this is how you get the entire fruit list. So this is what I was trying to do. Okay, fruits of 0. Okay, here I will show you. Here I will just say this print print the first item in fruits list is, and I will just say plus over here, and then I will say fruits of 0. Okay, now you can see that we printed the first item in the list, right? So here, if I do fruits of 0, it will come there. right? It came there as a value, so that is how you go ahead and do the list access. Indexing is what I just did now, accessing items by their positions, right? Accessing items by their position. Then we have slicing. Uh, so we will check that now. Slicing is a powerful way to get a portion of the list, right? So we just do start, stop, and step. Okay, start is where the slice begins, and stop is where the slice ends, and then step is the number of items to skip between each step of the slice, right? So now we will declare some variables called as numbers. Okay, I will just do it here. We declared these list item called as numbers 0 to 9. Now we will just get the items from 2 to 6. We start at 2 and we end at 6, right? So we will just put this over here, slice numbers 2 and 6. Now we just print the slice, print, and then slice of 1. And it will just give me 2, 3, 4, 5, right? So 2 is 0, 1, 2, so it started there. And then up to 6, 3, 4, 5, and it stopped here, right? So you can print those values. That is called as slice. For example, I will just demonstrate another one. Slice 2 is equals to numbers of 0 to 4. It should give us the 6, 7, 8, 9. Okay, when we print, and I will just say slice of 2, and actually it should omit the 5, 6, 7, 8, 9, and that happened. That started at 0 and it stopped at 4, right? 0, 1, 2, 3, and it printed the 3 of these because we put 0 and then 4. The fourth item is where it stops, okay, and that is how it is. Okay. So one more example might be start, stop, and finish, right? And step. This is slicing at the end. We want to look at the step ones. So basically, this is the same example. Here, I will just say slice 4, and then I will just print the slice of 4. And look at this output. It says 0, 1, 2, 0, 2, 4, 6, 8. Why? Because we are stepping 2 over here, right? So 1 is omitted, and then 3 is omitted, and then 5 is omitted. You are getting the even numbers. So similarly, you can get the odd numbers as well by doing 3 over there. Okay, let's try that. Slice 6, and then I will say 3 over here. Slice S6 is equals to numbers of 3, and then over here print S6. It says 0369. Do you understand, guys, what is slice? Very good. Now, this is all we have for today. Okay. And thank you so much for watching. I will end the stream. If you like what I'm doing, please subscribe to the channel